Welcome to this explainer. Today, we're taking a massive list of 30 common interview questions and distilling them down to the absolute essentials. We're going to cover the top 10 things you absolutely must know about Docker. So whether you're a total beginner trying to figure out all the hype, or maybe an intermediate developer looking to really solidify that foundational knowledge, you are in exactly the right place. Let's get into it.
Okay, to really understand Docker, we need to confront the single most frustrating, universally understood excuse in all of software engineering. You know the one. You've either said it yourself, or you've definitely heard a coworker say it when a deployment crashes and burns on the live server. But it works on my machine, right? That phrase literally represents hours of lost productivity, frantic debugging, and absolute configuration nightmares. And honestly, it's the exact pain point that gave birth to the technology we're exploring today.
To banish that excuse forever, we'll be covering 5 essential areas: the deployment problem solved, Docker versus virtual machines, images versus containers, navigating the Docker ecosystem, and we'll wrap up with the complete Docker workflow.
Let's start right off with Section 1, the deployment problem solved.
If our main goal here is to totally destroy the "it works on my machine" problem, well, we need a tool that guarantees the environment where you write your code is exactly the same as the environment where you run it. And that brings us to question number 1. What exactly is Docker? Think of Docker like a giant, universal wrapper. It's an open-source containerization platform that doesn't just look at your application code. No, it literally scoops up the code, all of the dependencies, the software libraries, and the exact configuration files, and bundles the whole shebang into one single, standardized, isolated unit called a container. It basically ensures that if this container runs fine on your laptop, it's going to run exactly the same way on a testing server or out in the cloud. And that perfectly tees up question 2. What are the benefits? Well, because you're shipping this complete isolated package, you get perfectly consistent deployments. There is absolutely no more guessing if the server has the right version of a software library installed. This means much faster delivery of your features. Plus, because containers are incredibly lightweight and portable, scaling your app up to handle massive web traffic is super easy.
Moving right along to Section 2, Docker versus virtual machines.
Now, packaging apps for isolated deployment isn't exactly a brand new concept, which naturally leads to question 3. Is a Docker container really just a miniature virtual machine? People ask this all the time, and the answer is a resounding no. They operate on entirely different architectural principles.
So, question 4. Why is Docker so much faster? Historically, virtual machines are incredibly heavy, right? Because every single VM requires a fully duplicated operating system. That means high memory usage, guzzling gigabytes of space, and a slow startup time that can literally take minutes. Docker, on the other hand, doesn't duplicate the OS at all. It just shares the host operating system's kernel. This makes Docker incredibly lightweight. Containers start up in mere seconds, use just a fraction of the memory, we're talking megabytes here, and they are vastly more portable across different environments.
Let's dive into Section 3, images versus containers.
Question 5. What actually goes inside Docker? When people first start using the platform, they almost always get tripped up by the terminology, specifically confusing images with containers. To really grasp this, we need to separate the concept of an architectural blueprint from the physical house it eventually builds. So, question 6. What is an image? Think of it as your read-only architectural blueprint. It's a static template that contains absolutely everything required: your app code, the runtime environment, all the system libraries, the dependencies, and your specific configuration files. And what's really brilliant here is that these images reuse shared layers. If you have 10 images that all need the exact same basic operating system layer, Docker only stores it once. It keeps everything incredibly compact and efficient. Which brings us to question 7. What is a container? Well, when you take that static blueprint and you tell Docker to actually run it, you get a Docker container. The container is the living, breathing, isolated runtime instance of that image. It is the actual physical house built from your blueprint.
So, just to summarize the matchup here, an image is a read-only template that can't execute on its own, and you create it just once. A container is the active running instance that actually executes your application, and it has a read-write layer. And here is the absolute best part. Because the image is just a static template, you can spin up hundreds of identical, independent containers from just one single image and have them all running simultaneously. How cool is that?
Okay, Section 4, navigating the Docker ecosystem.
Question 8,
how do we actually build and store these images without completely reinventing the wheel every time? You certainly don't have to build every single piece of software from scratch when you sit down to code. The true power of Docker really lies in its massive community and standardized tooling.
Let me introduce you to Docker Hub. This is the largest public Docker registry in the world. Just think of it as an enormous cloud-based library for developers. It's where you can securely store your custom images, share them with your team, or just download official pre-configured images from a repository of literally millions of ready-to-use options. Need a database or a web server? You just pull it down and it's ready to go, saving you hours of tedious setup time.
Question 9. How do you customize your own environment? You use something called a Dockerfile. It acts as an automated plain text recipe. You literally just write out the instructions, like what base image to start with, what files to copy in, and what commands to run. The Docker engine then reads this file and builds your application's environment layer by layer, perfectly every single time.
Now for question 10. If containers are meant to be destroyed, how in the world do we save our data? Remember how we said containers are ephemeral? If a container is deleted, everything inside its read/write layer is completely destroyed. We solve this by using Docker volumes. Volumes are external storage mechanisms that sit safely outside the container. They plug into the container, but if that container dies, your vital data, like database records or user uploads, lives on securely inside the volume, perfectly safe.
And finally, Section 5, the complete Docker workflow. This brings us to the ultimate test of everything we've learned. What does the exact deployment sequence look like to take your code from a laptop all the way to a live server? Let's map out the complete 6-step workflow that powers modern software development every single day.
All right, here's the journey of your code. Step 1, you write your Docker file defining the exact environment your app needs. Step 2, you use the Docker build command to turn those instructions into a static, read-only image. Step 3, you use Docker push to upload that image to Docker Hub or private registry. Step 4, when it's time to go live, your production server uses Docker pull to download that exact same image. Step 5, the server uses Docker run to spin up a living container from that image. And Step 6, boom, your application is officially deployed and serving users.
By mastering this standardized workflow, you achieve the ultimate victory. Because you package the entire environment, you ensure your software runs with absolute bulletproof consistency. It literally does not matter if the code is running on a dusty old laptop in a coffee shop or on a massive enterprise cloud cluster on the other side of the world. It is going to behave exactly the same way.
You now possess the foundational knowledge to understand one of the most transformative technologies in all of modern computing. You hold the power to guarantee your code runs flawlessly, anywhere, every single time. So, my question to you is this. What frustrating, brittle, difficult-to-deploy legacy project are you going to wrap in a container today? Thanks so much for joining me for this explainer, and hey, happy containerizing!